Good afternoon, this is Schweitzer, and this is a little introductory video on just the ins and outs of Hess's Law, how to run it, and I'll show a couple of practice examples here. A couple things about Hess's Law. One, you're going to be given a series of reactions. You'll see a couple examples right here. And in the end, what's big idea here is that we have a couple individual reactions that are running, and these individual reactions are each going to have an overall delta H. You can think of this delta H kind of like money in a checkbook. In a checkbook, you have money that's entering and you have money that's exiting. And if you add up all the positives and subtract all the negatives, you get your overall balance of money. And that's really what happens here. So we have, for each individual reaction, we're going to get a delta H. And you just take all your negative delta H's and you have all your positive delta H's, and you simply add the two together for an overall delta H. And at this point, that delta H is the net result. So Hess's law really talks about simply the fact that you're going to add up the individual delta H's to get an overall delta H for the reaction. Now, this only works if the individual reactions actually add up to the overall reaction. So by adding up, I mean that you could combine all of the reactants, combine all the products, cross out like terms, and what you have left would be this guy right here. If that's not the case, well, then you can't add these guys up. So the game starts when, at that point, we want to manipulate these guys so that they can add up to equal the overall. And if that happens, well, then I can go ahead and add these up and I have my answer. So the most common example is to do that. Look for an overall reaction. They could, however, change it up a little bit by giving you the overall delta H and solve for an individual reaction. It's no different, but you solve it a little bit differently. But either way, solving for a variable. All right, so now in this thing, what do I do for this? Okay, well, first of all, my first step that I do is to make sure that your reactants or products are on the correct side, meaning that, for example, here I have hydrogen peroxide as a reactant, but in my individual step, it's a product. So when I add these up, this guy's going to end up on the product side. That's not going to work. I need this guy to be on the reactant side. So I just make sure that my reaction is working the right way, meaning that my actual reactants are actual reactants. So my options one is I can flip a reaction. When I flip a reaction, I convert my delta H from a positive to a negative or vice versa. It goes back and forth. Okay. So first things first, we're looking to flip reactions to make sure that reactants are the reactants. Now, I don't have to check all of them. In an individual elementary step, I just got to check one of them. As long as one of these guys matches, well, then it's okay. So I'm going to flip this thing now. In this case, I could just take it and I'll rewrite it. And I normally would not rewrite this because it takes too much time, which is fine. Time doesn't really matter that much, but when you recopy this thing, you can really make some clerical errors. So I typically would just take this guy and make it 188 like this. Okay? So I'll rewrite this for now, but keep in mind I would not normally do this. 202 goes to and comes from H2 plus O2. Now I'm going to add these two guys together, but let's check this one. Okay, H2 is a reactant. It's not located here, so it must be getting canceled. So I can cancel it. I remember I flipped this one, so now this would cancel with that, which is a good indication that this is set correctly. But let's verify that one more time. Water is a product, and water is a product. So The fact that things are lining up correctly here means this guy does not need to be flipped. So we're good. The second step for this guy is simply quantity. All right, so now are the quantity of the numbers correct? All I do is check one item. If one item works out, they're all going to work out. So 1 H2O2, and I have 1. That guy's fine. This guy, waters. 1 water, 1 water. Okay, now this guy is delta H equals positive 188. And I'm adding these two guys together right here. And at that point, we're all set. And that 8, that's a 4. Okay, so carry up here, we got 7, and that's that, carry the one more here. So we got 477. Cancel that. We're subtracting those guys. Let's grab a calculator quickly. So it's going to be a negative 286 plus a 188 equals negative 98. Okay, so this guy here, that we're subtracting those negative and positive, is going to be a negative 98. Just grab your calculator and run it through. Now this is kilojoules per reaction, and it's for this reaction right there. These two halves will add up to that guy. But this is the general process which I follow. All right, so let's try another example. Now I'm going to go a little bit quicker through this one because I just want to show you how I do it. I'm looking for this process. Now again, the hardest part about this is to recognize that you actually need to use this method. But you should be somewhat ready for this, especially during the chapter. But all right, so I got a reaction here, and I got a reaction here, and it wants to know this guy. So you need to ask yourself, well, is it possible that these could cancel out and add up to that? All right, so first things first. This guy, this is a main cog here. It's a reactant here. It's a product here. So I'm going to flip this guy to a positive 226.7. Here, carbon dioxide is not present here. Carbon monoxide is not present here, but oxygen is, and it's a reactant here. So that being said, this thing looks like it's all set. Plus, the carbon monoxide is going to cancel with a flipped version of this guy. So that will be on the product side. So it will cancel there, and the carbon dioxide cancels here. Perfect. Okay, this guy is set up nicely. All right, next thing is quantities. One of those guys, one of these guys. Quantities are just fine. Now here, these guys. I need to make sure my quantities match. I have a half, and I have 3 halves. I need 3 times as many of this. Not to mention the fact that when this carbon monoxide cancels here, there's 3 of these. I need 3 of these to cancel. So this guy is going to get multiplied times 3. That's 3 halves. Whenever you're multiplying a fraction, just multiply the numerator. Leave the denominator alone. And then 3. You'll find at this point, I'm all set. Everything will cancel. Now, you can add everything up if you want, but if you go through these 2 steps, it's going to work. This guy gets multiplied by 3. Keep in mind, you flip it, you flip the signs. When you multiply, or if you divide, then delta H is dealt with proportionally. Okay, so this is going to be 283 times 3. 283 times 3 equals a negative 849. All right, so we got a negative 849. Okay, so now I simply add these 2 up. A negative 849, and then we're going to take away the 26 because it's going to be subtraction, minus the 26.7 gives me a negative 822.3. And the delta H of this reaction is a negative 822.3. That would be kilojoules per reaction cycle. All right, let's try another one. Again, they go pretty quickly here. All right.
Alright, so what do we got here? We got this guy right here. I think this is it. Try this one more here. You can try the last one, check your answer key. I might even go through a whole calculation, just set it up here. Alright, so we have two reactions. Now look, sometimes we refer to these as elementary steps, but really they're just reactions that add to an overall reaction. So carbon is on the correct side. Okay. Alright, carbon's good. Carbon's good. That means this thing's set up correctly. Carbon monoxide. Carbon monoxide is a product, so this guy is going to get flipped to a positive 283. All right, next one, quantities. One carbon, one carbon. All right, that guy is good. And carbon dioxide is one here, there's one here. Okay, quantities are good. Add them up. This thing's going to be slightly negative just because the negative is bigger than the positive. And you can do the math on that on your own. And that's all I'm really going to mention here about Hess's law. Thank you very much.